The next rule states that the abbreviations which are used for some ligands should be in lowercase and enclosed in parentheses. Like abbreviations are used for ligands like your ethylene diamine, it's written as EN. Acetyl acetonato, it's written as ACAC. Bipyridine, written as BPY. So what this rule says is that you cannot write the metal and start your abbreviation. First of all, you cannot start it with a capital letter. That's wrong. You have to start your abbreviation with a lowercase, and the abbreviation also has to be enclosed in parentheses. En has to be enclosed in parentheses when you are writing the formula. Di-En has to be enclosed in parentheses when you are writing the formula. The number of cations or anions which are written outside the formula are calculated on the basis that the total positive charge must be equal to the total negative charge. This entire complex has a charge of -1. Now I need to make this entire complex a neutral complex. So accordingly I'll add ligands outside. If there is -1 on this entire complex, this means I want +1 outside. So this negates or balances the -1 on the complex. So I'll write just one potassium outside. So this is what it means by total positive charge must be equal to the total negative charge. The +1 of potassium is equal to the -1 of AgCN2, and the +1 cancels the -1, and the charge on the total complex comes out to be 0. The next and the last rule is that the formula of a coordination complex without a counter ion, in which there is nothing present outside, the charge is written on the top right hand corner outside the square bracket. So this complex has a charge of 3 positive, so it's written on the top right hand corner outside the square bracket. Similarly for this also, the charge is written on the top right hand corner of the outside square bracket, and in case it is 1, then you do not need to write 1 negative, you can just directly write negative. If you just write negative, by default we mean that it's 1 negative. So now let us do some questions on how to write formulas if you are given the name. So the question states, which among the following will be named as potassium dicyanoargentate? Okay, so it's potassium, so obviously potassium is present. Cyano is the name for Cn negative. Now all of your options A, B, C and D have Cn. So now it's written, it's dicyano. Dicyano means there are 2 Cn ligands. So your option A or B could be correct. Now whether your option A is correct or whether your option B is correct depends upon the number of potassium atoms. So you have to determine the number of potassium atoms that will be present. How do you determine that? You calculate the charge on the complex, just the complex, that would be. So that is Ag plus 2 into Cn. Charge of Ag or the oxidation state of Ag plus 2 into the charge of Cn. Now it's written that dicyanoargentate 1. This one states that Ag is present in the oxidation state of +1. So +1 plus 2 into -1, because cyanide or Cn negative has a charge of -1. So that gives an overall charge of -1. So the -1 charge will be balanced only by 1 potassium. So that is why your option A is correct, because here only 1 potassium is present. In option B there are 2 potassiums present, whereas the overall charge on the complex, just the complex, that is the coordination pair, is -1. So obviously there cannot be 2 potassiums present. There can only be 1 potassium present, so that the overall charge of the entire complex including the ligand which is present outside is equal to 0. This was the first question. Now let's go to the second question. Second question states that which among the following will be named as tetra aqua dichlorochromium nitrate. Okay, let's make some things clear right now. Nitrate is NO3. Chromium, you know, is chromium. Aqua means water. Aqua is water. And tetra means that water is present 4 times. And dichloro means there is Cl ligand present and it is present 2 times. So, this is satisfied by both A as well as B. Now, among A and among B, which one is the correct one? So, among A and among B, H2O here is written before chlorine. That's the only difference. In this, H2O is written after chlorine. So, we will have to see which one will come first in alphabetical arrangement. So, H2O has H and Cl2 has Cl, right? So, Cl comes before H, so Cl will be written first and therefore your option B is correct. The next question asks you which among the following will be named as tetra aqua dichlorochromium 3 nitrate. So, tetra aqua dichloro, aqua here represents H2O ligand, that is aqua represents H2O, and there is tetra aqua written, this means the H2O is 4 times. Chloro represents chlorine and there is di written, so this means the chlorine is twice, and the chromium has a 3 oxidation state. So, all of your A, B, C and D have chlorine twice and H2O 4 times. What is changing between A, B and C, D is the number of times nitrate is present outside. So, to determine the number of times nitrate will be present outside, we will have to determine what is the charge on the coordinations pair. So, let us try to find the charge on the coordinations pair that will be equal to the oxidation state of chromium, which is 3. Here it is 3, so it is 3 plus charge of water, that is 0, plus 2 into minus 1, which is the charge on chlorine. So, that is 3 minus 2, which is equal to plus 1. So, the overall charge on the coordinations pair is plus 1. That means we need to have a charge of minus 1 outside. Now, the nitrate NO3 is a negative ligand, it has a charge of minus 1. So, if NO3 is present twice, this means the overall charge outside the complex will be minus 2, whereas the charge on the complex is plus 1. So, this is wrong. So, option C and option D are incorrect. So, option A and option B are still in the running for the correct answer. They differ on the way the complex or the coordinations pair has been written. So, in your option A, H2O is written before chlorine, and option B, chlorine is written before H2O. In H2O, the first symbol will be H, and in chlorine, the symbol will be C. So, C comes before H in alphabetical order. So, your B option will be correct.